Hey everyone, today we're going to finish up chapter 7.4, Confidence Intervals for a Proportion. Our objective is to determine the sample size required to obtain a C% confidence interval for a population proportion with a specified margin of error. All right, so let's take a look at how to do that. So here is the question that I am proposing here. Let's say a candidate is planning a poll and wants to estimate voter support within 3%. So with a 3% margin of error with 95% confidence. How large of a sample does she need? So what we're going to do is figure out, what sample size N is going to give us the appropriate values for this and this here. So how large of a sample are we going to need? All right. So when planning a study, we may want to choose a sample that allows us to estimate a population proportion with a given margin of error. So in that previous question, I was giving you a margin of error of about 3%. Now, this is the margin of error formula that is part of the confidence interval that we construct. So ME is equal to Z star times radical P hat times 1 minus P hat over N. It's a formula that you are very familiar with. So in order to calculate sample size, what we're going to do for this part of the lesson is just substitute values for the margin of error, for Z star, and for P hat. And what we want to do is just end up solving for N. So a lot of algebra work today, and it's what is the value of N here? How do we get N by itself? We're going to get all those values, plug them in, and try to solve for that N. All right, so there are a couple of ways to find P hat, okay? So this slide addresses how do we get P hat, all right? And there are two ways to do this. For one, you can use a guess for P hat based on a pilot or a preliminary study or past experiences with similar studies. And another way you can use P hat is to always use 0.5 as a guess. All right, so the margin of error is largest when P hat is 0.5, so this is a conservative guess. If we get any other P hat when we do our study, the margin of error will be smaller than planned. So P hat is a good conservative guess again. It's going to give you the largest margin of error. So you just use that to be safe if you don't have this P hat based on a preliminary study. All right, so we're going to go ahead and skip that slide. But here's an example that we're going to try out. And it says, suppose that you want to estimate P equal the true proportion of all students at your school who have a tattoo with 90% confidence and a margin of error of no more than 0.07. How many students should be surveyed? So in other words, what is our N? How many students do we need to survey? What should our sample size be? All right, so you're going to start the problem off with this part of the confidence interval calculation, just that margin of error. It's just that portion, your Z star times your standard error. And we're gonna substitute 0.07 for our ME. We're gonna get our Z star from 90%. So remember, on your calculator, it's inverse norm 0.90 center area, and I've already talked about how to get it on Staplet numerous times. So you're gonna notice a 90% Z star is 1.645. All right, and since no other P hat value is given, we are going to go ahead and use a P hat of 0.5. And again, that's a conservative estimate, and that's totally fine to use when you don't know the P hat value. All right, so now we're going to plug those values in. You'll see them plugged in right here. Margin of error, 0.07, Z star 1.645, P hat and 1 minus P hat are going to be 0.5 and 0.5. So that all gets substituted in here. All right, so now this is going to be an algebraic exercise in order to get n by itself. So we're going to use a lot of properties that you've used in your algebra class. This might be the most algebra you've done all year. So in order to first get n alone, what I notice here is these two constant values that we can try to well, we want to get rid of this 1.645 attached to this radical here. So we are going to divide both sides by 1.645. So that's what we did here in this step. We're dividing both sides by 1.645 so that we can eliminate that value away from the radical. So at the same time, we divide it to this side. And notice I'm going to leave this alone because this is going to give us a really nasty decimal. So I'm going to leave 0.07 over 1.645. Now down here, what you're seeing in this step is I am now going to square both sides. And remember, I am going to square it in order to get rid of this radical. So squaring is the inverse operation of taking the square root. So that will simplify. And now we can go ahead and figure this out on our calculator. We can take 0.07 divided by 1.645. And if you group it just like this, your calculator will give you an answer. So up here, this entire quantity now becomes 0.00181077741. Try not to round too early. Okay, there's a reason why I didn't divide this, because if you divided these two numbers, you probably would have rounded, and then you would have squared that number. And then here, you may be tempted to round again. So we're trying not to round until our very, very last calculation. And that leaves us here. I also went 0.5 times 0.5. So there was a lot going on in that step. And we get 0.25 over n equal to this decimal here. So we're almost there, all right? Now, what I did here is I cross-multiplied. I'm going to cross-multiply here. Just put a 1 under that decimal and cross-multiply. And that gives us this equation here. And we are almost done. The very, very last step now is to divide by this number here that's just attached to the end. So I just divide both sides by 0.0018107. Oops, sorry about that. 7741, which will cancel that out. And again, the same thing here. I'm going to run out of room, so I'm just going to write 0.00018. And if you have done all of that correctly, you will probably end up with a number you end up with about 138 and some change. Now, why did I round up? Because you want to round up because larger sample sizes give smaller margins of error. If you round down, you may risk getting a margin of error greater than 0.07. So at the end, it's safer to always round up. And that number 138, again, I know it's like very, very close to 138. It's much closer to 138 than it is to 139. You still round up to make sure that you have a margin of error of no more than 0.07. Again, a larger sample size gives you a smaller margin of error. So just to be safe, you round this up so that you do not exceed a margin of error of 0.07. All right, let's try this problem out. So please pause the video and give it a shot, and check back when you are ready, and we'll go through the solution. All right, so a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One value of interest is the proportion P of customers who are satisfied with the company's customer service. She decides that she wants the estimate to be within 3 percentage points at a 95% confidence level. How large of a sample is needed? So how many customers will she have to sample? We have our ME right here. ME will be 0.03, and a Z star at a 95% confidence level. This is one of the most common ones that I mentioned you should memorize, and that's 1.96. Since we don't have a prior study here, we're going to use 0.5 as our conservative p-hat estimate. All right, so with these three values, we have enough to find our n. So here we go. We use that margin of error formula. That's part of the confidence interval. And we're going to plug in our margin of error, plug in that Z star value here, plug in our p-hat. So if p-hat is 0.5, then 1 minus p-hat will be 0.5. Okay? So remember, next step is division. Divide both sides by 1.96. So these will cancel out. Don't divide this quite yet. Just leave that alone. And then we're going to square both sides to undo the square root here. Okay? So now you have 0.03. So enter it in your calculator just like this. Group the fraction, put a parenthesis sign and take 0.03 divided by 1.96. Close it and then square it. Now, your calculator may say something like this: 2.34 times e to the -4, or something along those lines. Remember, this is scientific notation, and what you're going to do is you move this over 4 decimal places to the left. And what that will leave you with is 3 zeros in front of that number. So you're going to have 0.000234 and so on and so forth. Okay? So that, don't be alarmed by this. If you have a TI, it will probably default to this. So this is the value you want to write down. Okay, now put a big 1 under that and cross multiply, which leaves us with this. Again, please try not to round too early. Okay? And I'm going to divide both sides by this value. So if this number happens to be stored on your calculator, remember that your TI has an answer key. And if you divide 0.25 by the answer that's stored on your calculator, you may not have to type this over again. This may be stored and ready to work. So 0.25 divided by the answer, which is this value right here, gives you 1067.11, I believe. And again, you're going to round up. Always round up because you don't want to exceed 3 percentage points of margin of error. And if you round down, a smaller sample size will give you a larger margin of error, and you want to make sure you don't get a larger margin of error than intended. Okay? And here is a quick explanation of why. Again, a smaller sample size results in a larger margin of error than the desired 3 percentage points. So always round up, which takes you to 1,068. So you need 1,068 customers. All right, one last problem here. I wanted to give you a problem where you don't use p-hat 0.5 because you do have a prior study. So this very last problem, you're going to use 80%, or in other words, a p-hat of 0.8. Okay, so please pause the video. Everything else is the same. 3% margin of error, 95% confidence. Please try that out and check back for the solution. All right, so here we go. So I'm going to go through this very quickly because I'm almost up to my 15-minute time limit. All of this is the same. The only difference is p-hat is 0.8, which means 1 minus p-hat is 0.2. Think 80-20. All right. Now getting through all your work here, will leave you with a sample size of 683 people.